video 3.5, and it does not go with 3.5 in your textbook, but it is a concept that you need to know how to do. It's actually from the Engage New York module. It's lesson 8, but I'm calling it 3.5 just to stay in order. Linear equations in disguise. So in this, the outcome for you, students will rewrite and solve equations that are not obviously linear equations using properties of equality, good equation solving properties. So there's a theorem that says given rational numbers A, B, C, and D, so that B and D are not 0, right? Cannot divide by 0, A over B, if A over B equals C over D, then AD, their cross products, are also equal, equals BC. You know this as a proportion. So I know that 1/2 equals 3/6. And yes, 1 times 6 is equal to 2 times 3, also 6. So the product of the means equals the product of the extremes. That's the theorem. To find a value of x, we can multiply each numerator by the other's fractions denominator. So 12 times x, each numerator, it's cross products. 12 times x has to equal 6 times 5. So then when we solve that, 12x equals 30. So x would have to be 30 twelfths, dividing by 12 on both sides, which would reduce to 5/2. So we're using the properties of equality, dividing by 12 on both sides. That's a property of equality. The cross products, that's the proportions property that says that the product of the means equals the product of the extremes. In this lesson, our work will be similar, but the numerator and or denominator of the fractions may contain more than one term. They may be a binomial. They may have a variable in them. However, the way we solve these kinds of problems still remains the same. Variables on both sides of the equation, we still solve that way. So, given a linear equation in disguise, we will try to solve it. To do this, we must first assume that the following equation is true for some number x. So, the equation x minus 1 all over 2 equals x plus 1/3 all over 4. We want to make this equation look like the linear equations that we're used to, having distributive property in them, having an x on both sides. So for that reason, they're going to cross multiply. They're doing the product of the means equaling the product of the extremes. So it ends up looking like 2 times the quantity, x plus 3, when you cross multiply here, and some kids like to draw the bubbles. I don't always like to draw them because then you draw on top of the math. So, but that's what it is. The product of the means, 2 times the quantity x plus 1, those are the means, equals the product of the extremes, 4 times the quantity x minus 1. Is this a linear equation? How do you know? Yes, this is a linear equation because the expression on the left and the right of the equal sign are linear expressions. They have variable terms in them. Notice that the expressions contain more than one term. They're a binomial. So you do have to distribute here. Now that we have a linear equation, we can use the distributive property of equality, distributing 2 to x, and you can see this one is solved for you. And then they distribute the 4 to the quantity x minus 1. Then they decide to subtract 2x, the smaller x, from both sides. You can see all the work here. 2/3 is then equal to 2x minus 4. Adding 4 to both sides, you get 14/3 equals 2x. Dividing by 2 or multiplying by the multiplicative inverse, 1/2, you're going to get 7/3. Ooh, that's hard to see that. 7/3. 7/3 is equal to x. On the next page, you can see that the check here. Does this 7/3, is that the solution to this equation? Yes, it is. By replacing my x by 7/3, it's not really easy. However, not so bad on the right side. You get 8/3. 7/3 take away 1, which would be 3/3. You get 4/3. So is 4/3 over 2 equivalent to 8/3 over 4? Multiplying the cross products, 2 times 8/3. So they did that cross multiplying again in the check. Is it equal to 4 times 4 thirds? You get 16 thirds equals 16 thirds. Yippee. On we go. So since 7 thirds made the equation true, then we know that it is the solution to this equation. So the next oh, come on, no. Oh, my board's not lining up. Here we go. Example 2. Can we solve this equation? So again, we need to multiply each numerator by the other fraction's denominator. Product of the means equaling the product of the extremes. So 7 then distributes to the 2x plus 9, and the 3 distributes to the 1/5 and negative x. So you get 14x plus 63. Does it equal 3/5 x minus 3x? Yes, this is a linear equation because there's linear expressions on either side of the equation. Oh, did we finish solving it? No, we didn't finish solving that one. Oh, come on. How do you know this is a linear equation? I'm going to go ahead and finish solving this. Why not? They didn't finish it here, but I'm going to. So 14x plus 63 equals 3/5 minus 3x. Smaller x is the minus 3x, so I'm going to do the opposite, add 3x. Oops, add 3x to both sides. And I get 17x plus 63 equals 3/5. Subtracting 63. Ooh, this is not going to be so easy to solve now that I've started this. I get 17x equals 3/5. Take away 63. I'm going to get a calculator. 3/5 take away 63. Oof, not so easy. 3/5 take away 63 gives me negative 62 and 2/5. Oh, no kidding. I knew that. So I get negative 62 and 2/5. Dividing both sides by 17. Dividing both sides by 17. I get 3 and 57/85. Negative. So negative 3 and 57/85. Well, that was the hard part. I could have done 3/5 take away 63. No kidding. Negative 62 and 2/5. So I did use a calculator to help me get this. We could do the check, but we'll save that for another time. So going on. Example 3. Can this equation be solved? Well, first thing we need to know, is it a linear equation? Yes, it is. I can do my cross products. Yes, we can solve the equation because we can multiply each numerator with each other's denominator and then use the distributive property to solve it. So the product of the means is 7x at plus 2/3 multiplied by that numerator 3. Well, I'm going to put that out front. Has to equal product of the extremes 8 times the binomial 6 plus x. Okay, so I'm getting 21x when I distribute here, 21x. 3 times 2/3, well, that equals 2 because those 3's cross cancel, equals 48 plus 8x. Distributing correctly here. The smaller x is the 8x, so subtracting 8x from both sides. I get 13x has to equal 13x plus 2 has to equal 48. Subtracting 2, I get 13x equals 46. Dividing by 13, using all those good properties of equality, I get x is equal to 46/13. And I'm going to leave it rational like that. X is equal to 46/13. And again, I'm checking this, and I did check it. It is the correct answer. I know it's 46/13. Not such an easy check because of those rational numbers. So I'm going to not use the time on the video to show you that check, but it does check. So the next example, example 4. Can this equation be solved? If it's a linear equation, the answer is yes. And I got, using my cross products, the product of the means, 3x plus 9 times 1. Well, that's kind of silly. 3x plus 9 times that 1. That 1 I'm going to put out in front. I could put it back here and then distribute this way. I just don't like putting it at the end. So, yes, I'm going to put it out front times my binomial 3x plus 9, just as 3x plus 9, equals 7 times 8 is 56. This one's much easier. So 3x plus 9 has to equal 56. I'm not going to distribute 1 because that's kind of silly. So when I subtract 9 from both sides, I get 3x equals 47. And dividing by 3, x equals 47 thirds. Again, a rational answer. 47 thirds times 3 is going to give me 47. 47 plus 9 is 56. So I get 7/56. Does that equal 1/8? Yes, it does. They are equivalent ratios. So that is a solution to that equation. Example 5. Now, we haven't learned a lot about similar triangles. You may remember this concept, you may not. So I'm going to have to help you a little bit with this. Using what we know about similar triangles. In similar triangles, the angles are the same and the sides are proportional to each other. So we know that angle A and angle A prime are the exact same angle. Similar means that the shapes have the same angle, same shape, but the sides are in proportion, different size. So some teachers will say similar means same shape, different size. And you can see that A prime, B prime, C prime is smaller, but it's proportional to ABC, triangle ABC. So setting up my proportion correctly, this x minus 2 and its related AB prime side over there, I'm going to put them in my first ratio. So x minus 2 is to 9.5 centimeters as, so large triangle again, my x plus 2 is to that 12. So small triangle AB side, large triangle AB side, x minus 2, is the corresponding side A prime, B prime in the small triangle, has to be proportional to the ratio AC in the large triangle to A prime, C prime. That's their corresponding sides. So you set them up in a proportion. And again, I can solve this because the product of the means, 9.5, times the quantity x plus 2 has to equal the product of the extremes, 12 times the quantity x minus 2. Oh, my board's off. Okay, here we go. So, distributing that 9.5x, I get 9.5x plus 19. Is it proportional to, or does it equal, yes, 12x minus 24 when I distribute both sides. My smaller x is the 9.5x. I'm going to subtract that from both sides first. Careful lining up your decimal points there. You may use a calculator to help. So 19 equals 2.5x, not 3.5, 2.5x minus 24. Adding 24 to both sides, I get 43 is equal to 2.5x. Dividing by 2.5 on both sides, dividing by 2.5, I get x equals 17.5, or 17 2/10. And yes, this does work. So the length of AB, if I put it back in, does it say we have to find, let's determine the value of x. Now that we know, find the lengths of AB and AC. Oh, they did want us to solve for that. So AB, which represents x minus 2, AB's length would be 17 and 2/10, take away 2, would be 15 and 2/10 centimeters. And the length of AC would be 17 and 2/10, the x plus 2, so it would be 19 and 2/10 centimeters. So it did ask us to do a little step up there and find the length of AB and AC. So, and we did that. The next example, and I'm not going to do all of these. The next example, number 1's pretty easy. I'm going to leave that one. If you want to try it, I'll go over it in class. If not, you don't have to. I'm going to leave that one for now. I'm going to do number 2. So using my product of the means equals the product of the extremes, 6 times 3x minus 1, my cross products, has to equal 7 times the quantity 5 plus 2x. So distributing, I get 18x minus 6 has to equal 35, and 7 times 2x would be plus 14x. The smaller x is the 14x, so I'm going to subtract 14x's from both sides. And I get 4x minus 6 equals 35. Two-step equation, adding 6 to both sides. Fourteen x has to equal 41. So when I divide by 14, I get x equals 41/14. X equals 41/14 for number 2. I would like you to do number 4. Number 4 has got 8 times that quantity, 2x plus a fourth. Not bad, not bad. And 5 times the quantity, 3 minus 4x. Watch the negative in that one. So I'm going to stop the video now, but I would like you to do number 4, and that's one that I'm going to do in class to make sure and check to see that you have that one done. If you want to try number 1 and 3, you may also do that. So that's it for today.